I hope you were able to hear me and you are also able to see my screen, right?
Yes, sir.
Mhm. Okay,
Yes, sir.
so now last day we discussed about the way the data was built up for the ProPublica study. So we had a like step-by-step discussion of how the entire data set in 3 parts was built in order to conduct the study. So today we will talk about the analysis that the authors did in order to investigate the existence of bias. So the first thing was a very simple thing. So they did a very simple distribution study. So what they did here was, so if you are able to see the pictures, right?
Yes, sir.
Yes, sir.
Okay, fine. Thank you for confirming. Okay, so on the x-axis, what you see are the compass scores from 1 to 10. Okay? And on the y-axis, what you see are the count of individuals that have that compass score. Okay, so these are count of defendants having compass score equal to x. Okay, and these are the compass scores. Now the data was divided into 2 parts, the blacks and the whites. Okay, now what do you observe from these two distributions? So these are the black defendants and these are the white defendants. So what is the first observation that you can make? Any significant difference that you note between the two distributions?
Sir, second one is decreasing.
That's fine. Look at the scale on the x-axis. These are the compass values. Doesn't this
Sir,
strike a bell? Go ahead.
sir, for
One
white
of
defendants, the values are continuously
okay,
decreasing.
okay. So that's all.
So white defendants are given a lower compass scores, meaning they are less likely to commit the crime again, whereas black defendants, on an average, have been distributed evenly among all the compass scores.
Very good. So basically, what you see from this two distributions is the following, that a very large number of white defendants, okay, are at compass score 1. Okay, and the number of people who are having high scores for white defendants is pretty low, whereas for the black defendants it is more or less evenly distributed. And not only that, defendants who are at high risk are sizable in number. Okay? So this is what is coming out from the distributions, from the two distributions. So white defendants typically seem to have low score. I mean, if you go by the counts, you see that the white defendants typically seem to have very low scores, and there are only a handful of them who have very high scores, meaning who are at very high risk. Okay. Whereas for the black defendants, this is not the case. The scores, or rather the counts, I should say, are evenly distributed. So some of you are on unmute. Do you have a question? Hello? Okay, fine. So I think there is someone who should be waiting in the lobby. Just a second, let me check that. There is someone waiting on the lobby. Yes, as I thought. Okay, so this was the takeaway from the first plot. Similarly, they looked into the data corresponding to violent recidivism. So the previous one was simple recidivism, the category of simple recidivism. So you have simple recidivism, blacks, whites, treated separately. The same thing was done for the subset of the data which corresponded to violent recidivism. And here again, you see a very similar trend. Okay? For the white individuals, low scores are dominant. Okay? Okay, so this is a similar trend that seems to be occurring in both the subsets of the data, both in recidivism, simple recidivism, as well as in the violent recidivism subsets. Now the question is, does this tell you much about the original objectives that the authors had set? So just by looking at these two distributions, can you come to some conclusion that, okay, the Compass software is biased?
Yes, sir.
You are with me, right? You have understood what I'm trying to portray here. I hope you are with me. If there is any confusion, let me know. We can repeat. But this is a very simple distribution that they have plotted. Let me know if you have any confusion. You guys are with me, right? Okay. So now the question is that what do we learn from this, and can we have a like conviction that okay, the Compass software is already biased from this analysis? So what do you think? Is there anybody who feels that this much is enough to show that the software is biased? No thoughts? Okay, who feels
Sir,
at least?
it is like because there is no other data based on like age or culture and other things. We
Mhm.
cannot say like because this is just simply the count. So the other parameters could be just as same as the like
No,
age and culture.
think like an AI expert, yeah, or should I say a data scientist? Like, why do you think from this uh, data set, like without going into any other culture, etc., why do you think that this itself is not sufficient? What could be the basic cause of this being an insufficient information? You are
Sir,
correct.
because we need to look at the ground truth distributions of the two communities as well.
Very good. So basically, what I think what you are trying to say is that probably in general, traditionally, the crime rates for blacks is larger than whites, right? That's what you're trying to
Yes,
point out?
exactly. Yes.
Yeah. So basically, this does not say much. One might claim by when you show this, one might claim, okay, traditionally black people have been like associated with more crimes, and that is what is getting featured in the distribution. What the heck in it in this? Okay. So this the distribution does not alone prove anything simply because the crime rates for the two communities might be different. And as a side information, we know that crime rates for blacks in the US has been usually large. So this alone does not prove much. And therefore, from this point of view, the authors motivated the two different experiments that they set off with. Recall those two experiments. One was this profile to the compass score. Okay, this match, they wanted to see this. And the second was the comparison with the ground truth. So these were the two objectives that they started off with, and we discussed that in length yesterday. Okay, so what did they do? So they came up with a different experimental setup. First of all, if you look carefully, you have the Likert scale of compass going from 1 to 10. Now, for simplicity and using the North Point's guidelines, the authors actually binarized the problem so that they could have a binary classification version. So they had the low zone as the zero class, sorry, let's call the low thing as the zero class, and the medium plus high as 1. So just note the kind of nuances that you need to take care of when you have to, like, build up such an experimental setup. Okay, so this is very, very important. Sometimes, as you will see, like in many of your term projects also, and in fact, in many data science experiments, I mean, not limited to AI and ethics, you will see that this building this pipeline is much more important or much more critical or intricate than actually doing the experiments. The experiments might be very simple, okay, but then building this pipeline, having a very clear thought process is something that is like that takes you a long way. Okay, so now, so that means this was, I think, if I remember correctly, 1 to 4, and this was like from 5 to 10. So these were the two subcategories. Now they used a very simple logistic regression model to predict low high. Okay. Now you need features, right? Training data. What do you think are the features here? From which among the 3 data sets that we gathered last day will the features be born?
First, but
The
profile.
profiles.
The profiles, very good. The profiles. So which would include age, race, gender, criminal records, or criminality, say the number of criminal records and so on and so forth. Okay, so these were some of the features that were used for the LR model. And now can you tell me, like, if you can tell me this last thing, then you will see that the whole experiment pipeline becomes very clear to crisp and clear to you. Now, can you tell me what they're going to do? There is this LR model here. You can have any machine learning model, like they used LR, like without any loss of generality, you can use any linear classifier for that purpose. So can you tell me, like, what they're actually heading on? So they discarded the distribution analysis and they went on for this kind of an analysis. So using
Like
these
how
features,
predictive race,
very
how
good.
predictive special features are.
Absolutely, yes. So basically, what they will do this prediction, they will run this model, and then from there, they would estimate the, what you call, the predictive capability of a feature. So do you see where this is going? So basically, they will try to find out the predictive capability of age, the predictive capability of race, the predictive capability of gender, etc. Okay, so given this model in the middle and given this prediction objective as to whether the compass score would be low or high, so how is this correlated with the different attributes or the different features of the defendant profile? Okay, so this is what they wanted to see. And what do they see? So you know how to measure predictive capability of features? You know how this is usually done? So I'll not go into details, but if you have done a machine learning 101 course, you should be knowing that there are tests like chi-square test, okay, information gain, or leave one out tests. Okay, so these kind of tests, any one of these variants are used in order to estimate the predictive capability of a particular feature. Okay, and that, so the authors used one of these to identify, in fact all of these correlate very well, one of these to identify the predictive capability of the different features. And what do they find? So this is the table. Okay, without looking on the right hand side, tell me what do you observe? So these stars here mean very significant. Statistically highly significant. So tell me, which one is the most predictive factor? Highly predictive as well as highly significant. No bell rings from the table?
Age less than 25.
Age, yeah, it's written of course on the other side, but anyway, so age is the most important factor, the strongest predictive factor. And it seems like defendants with age less than 25 have a much higher, I mean, are thought to be, or at least thought by the compass to be at a much higher risk than the others. Okay, than those which the, so then the middle-aged people. Okay, what else is coming up? What next?
Black.
Black. So this race is also, and mind you, now it is no longer just distributions. Okay, so all the other factors have been controlled well. Still, blacks come at the second strongest
important factor.
factor. Okay, and this is actually what is bothersome. Okay, in fact, the authors found that they are 45% at a higher risk than the whites. So this was kind of quite alarming. Okay. So now what is the third?
Sir,
Uh,
sir, what is represented by these three stars?
as I said, these are significance tests, some statistical significance test. I think the authors did something like Man-Whitney. So how significant are these results? You know how to do statistical significance tests? So basically, it tells you how significant. So for the sake of this class, let us assume that this tells you how significant the results are. In fact, it has a much deeper meaning. You can go back and look into Wikipedia to understand like a more detailed description of what is meant by significance test. But usually when you have to compare two distributions and when you have to show that these two distributions are different, you need to do some sort of significance test. Okay, you need to run some sort of significance test in order to do that. Okay, so for the time being, assume that these are like strongly significant results. So these are not like by chance. These results are not by chance. Okay, so what next? Among the profile factors, gender. See, gender is such a strong indicator. So this is again very alarming because in general, women have lower crime rates. But even then, even after women having lower crime rates, you see that women are at a higher risk of recidivism as asserted by the Compass software. Okay, so these are the two things that are quite bothersome. One is the race thing and the other is the gender thing. And especially when you combine race and gender, in this case, black female, the situation in the US is extremely bleak and black. And this is historically known. Okay, so any incidents that you know of extreme discrimination which came into highlight in the recent past?
George Floyd.
Anything from the uh, computer sciences or related to AI or specifically
Face
related to AI and
recognition for
ethics?
black people,
Huh?
like face recognition technologies.
Yeah, okay. Probably you don't uh, know the story. So many of you probably don't know the story. No, it's not related to face recognition. So it's discrimination against individuals, against black females.
Timnit Gebru.
Timnit Gebru, very good. So you know the story.
Yeah,
So
like she was fired from Google
yeah,
for like
Timnit Gebru.
paper.
So who was she? Who was she in Google?
AI and ethics head,
Yeah,
I think.
yeah. She was the AI ethics head. I think they call it lead. Now she wrote a paper If you are interested, you can go back and look into and search with the keyword stochastic patterns. Stochastic patterns. The case of large language models. And this paper was about like how the large language models are using a lot of computing resource and therefore putting forward a huge carbon footprint. Okay, and this included some of the language models that were released by Google itself. So you understand the conflict? So she wrote a paper, she was AI ethics lead. She wrote a paper like where she was talking about the adverse consequences of these large language models, like the amount of carbon footprint that these language models like put up, also the amount of discrimination. So they showed, so this paper was written along with her colleague Emily Bender. Okay, so together the authors showed that even if you take the entire data available on the web, even then you will not be able to resolve the discrimination between, say, ethnic groups like blacks and whites, caste systems as they exist in India, or certain religions. So even if you do, so the data is so skewed and so biased that even if you take the whole of the web and push it into your language models, this is not going to help. And therefore, you need to have alternative mechanisms to build your language models. Okay, and this was going against the policies and business rules of the Google leads, and therefore, like this was one of the closest and probably the truest stories behind her firing, and so this she was fired from Google. And like people believe that in general, there is a lot of racism as well as gender related discrimination inside this big banner company. And this was just an outcome of that particular tradition rather than on one single event of writing this paper. So that was the story. Anyway, so next, the authors did a similar experiment with the subset of data consisting of the risk of violent recidivism, and there also they found very, very similar results. So the age was the most predictive factor. As you see here, female again was at high risk, blacks were at very high, sorry, female here were at low risk. So violent recidivism was something that was not very much common in females. Okay, but blacks again, this ethnic group was again having a strong predictive capability of the compass score. Okay, so this was the one side of the story. Now, nothing gets complete unless and until you have strict comparisons made with the ground truth data, right? So this is what I told you. So that was the other side of the experiment that they did. Now, can anyone quickly tell me like what would be the other side logically, other side of the experiment logically? What would they plan to show in order to uh, uh, show that there is a bias that exists? What kind of study they would do? So they have the ground truth, the 2-year ground truth. Recall. So they had this 2-year ground truth of whether a crime was committed by a defendant. Okay. And they also had the compass score at some earlier point for the defendant. Now, what do you think that they are going to study? Any thoughts? Again, we will assume it's a binary stuff, low versus high. Okay, let me give you a hint. They are trying to build a contingency table. What should be here? The columns are low high, basically risks. What should be the rows? Think. It is important to think.
Gender.
No. You are looking at the ground truth, forward data, future data. What are you in search of? Tell me, what are you searching for here? How much does the compass score tally with the future risk of recidivism, right?
Yes, sir.
This is what you are trying to map. How much does the compass score tally? So compass has given some score to somebody and you want to see, like, if the person is given a high score, then this person has what? This person
Actually
has
committed.
actually committed a crime or not in future. This
Yes.
is what we wanted to see, right? So if compass has given a high score to someone, then whether this person has actually gone and committed a crime in the future, that is in the next 2 years time period. And if compass has given a low score to someone, whether this person has never committed a crime within the 2 year span. This is the kind of thing that you are trying to see, right? This is the ground truth
Yes.
match that you are wanting to make. So then you have on the rows survived and recidivated or reoffended. Okay. Now tell me, what will these numbers tell you? All my machine
Those true
learning
positive,
experts.
false, but true positive, false positive, those.
Which one is true positive? Which one is false positive? What is this first cell?
I think it is true negative.
True negative. Okay. What is the second one? False positive.
Yeah.
True positive. False
False
negative.
negative. Yeah.
Now, what the heck are they going to do with this? Now I
Find out the
have given
record.
you, now I have given you all the things on your plate. Okay. So what do you think are they going to do?
So we can calculate accuracy.
Accuracy of what?
So the
Like
model.
precision and recall also, how
Precision and
precise it
recall.
is.
Precision and recall. What is most important here?
False
Is
positive rate, I think.
very good. So what is important here are the misclassification rates rather than the classification rates. Why do you think misclassification rates are important?
That means the group, unjust sort of treatment is being
Exactly.
like
So there
false
is a saying,
conviction.
right? Some of you might be knowing that saying. What is that saying? Remind me. If in order to save one innocent, you have to, like, release 20 offenders, that is acceptable. But you should not actually convict a person who is guiltless. So that's why the misclassification rate is more important than the classification rates. So now with this objective, the authors tried to study the misclassification rates on the whole data, that is all defendants, black defendants, and white defendants separately. Okay. So again, just to remind you, so what is the false positive rate? How is it defined? How is the false positive rate defined? Come on, you should be able to tell this. Or am I asking two simple questions which you feel not worth answering? So the false positive rate is number of false positives by false positives plus true negatives,
True
which
positive, true
is
negatives.
the total number. You have to remember it like this: total number of negatives in your data sample. And if you calculate that for the entire data, it comes out to be 1282, which is close to 32.35%. Now, if you try to compute the same value for the black defendants, it comes out to be 44.85%. Okay, so this is obtained as 805 by 805 plus 990. Okay, so this is the false positive rate for the black defendants. Similarly, for the white defendants, the false positive rate is now. What is a quick observation from the false positive rates?
Blacks are being misclassified more.
The blacks are being much more misclassified than the whites. In fact, it is almost double the number of times that they are misclassified. So basically, blacks are found to be, or blacks are like adjudged to be at a higher risk by the Compass software 2 times as compared to the whites. Okay? They are wrongly adjudged to be at higher risk. So the blacks are wrongly adjudged to be at higher risk, and like this is 2 times more than the whites are wrongly adjudged. Okay. The other part is also very interesting. Now, if we compute the false negative rate, what is the false negative rate? False negatives by true positives plus false negatives. Okay. So this is the total number of positive samples in the data set. Okay. Now, if you calculate the false negative rates, what do you see? The false negative rate for the blacks is 27.99 and the false negative rate for the whites is 47.72. What does this mean? What does false negative rate, higher false negative rate indicate? Someone should answer.
Sir, bias in favor of
Guilty
whites.
people.
No.
So bias in guilty favor, like in the guilty case.
No. Bias in guilty case means be more clear, succinct. Hand wavy answer nahi chalega. Think, take a little bit more time, deep breath, think a little bit more time, a deeper breath, and then try to answer. So false positive rate you have understood, right? That is adjudging somebody to be at a higher risk falsely. That is the false positive rate. Okay. You are calling the, here this indicates you are calling the guiltless to be guilty. What is the false negative rate?
Sir, you're acquitting somebody who is guilty.
You are acquitting somebody who is guilty. Right?
Yes.
And this is larger for the white defendants. So white defendants escape much more than the black defendants. So again, this is close to 2 times. The probability that a white defendant will escape the eyes of the compass score is almost double the probability that a black defendant is going to escape. Is this clear to all of you? Making sense?
Yes, sir.
Knock, knock. Yeah. So the first one is convicting the guiltless to be guilty. And the second one is allowing the guilty to escape. Right? So these are the two rates are indicative of okay. So these were the prime observations which actually made the authors strongly claim that the Compass software is biased toward certain ethnic groups. So now you see so this is no longer a distribution. This is hard fact. You are looking at rates, error rates, and therefore error rates doing this kind of discrimination is really something that is worrisome. And the same thing actually also was true for the case of violent recidivism. Again, you see the false positive rate is much higher for the blacks compared to the whites, and the false negative rate is again far more high for the white compared to the blacks. Okay, so we will stop here. This concludes the first case study, and next week we will start with the second next study, which is also like very interesting in its own self.
Sir, I had a question.
Yes, go ahead.
Is the data sufficient for us to conclude, like these numbers 1692, 273, are they sufficiently high for us to conclude whatever we are concluding?
So this one is not so small, you see.
Yes, so is there some objective method to determine if it's...
No, so actually, like there is no objective method as such, but you can assume that like there is an underlying vibration in the community that at least 5K plus data is good enough.
Okay.
Okay. Typically nowadays people also like 5K has become a bit backdated, and people now prefer something which is like 10K plus. Of course, if you are doing it on 1K data, people will always immediately complain that this is like nothing significant could be drawn from here.
Okay, thank you.
Any other questions?
And sir, it is already established that the model is doing good job, right? The recall of precision is good.
Here
Before
there
this
is no
conclusion.
model. Think carefully, there is no model.
Okay, that compass score, yeah.
Compass score is there, and the
Yeah.
ground truth is there.
And
There
the
is no
ground truth thing.
the logistic regression was for like for the profile to
Yeah.
compass score.
For
So
the
there are
important, yeah,
so there are two
importance of the
parts.
attributes.
Absolutely. So there are two parts. This part is modelless. That part had model. So one was profile, LR, compass score. Here there is a model. But the second one is compass score.
And the ground truth, yeah.
Yes. Ground truth. No model here. And you just made a contingency matrix. So this is basically, as you will learn later on, this is basically an audit of the compass algorithm. So audit means how well the algorithm does. Like, you know, right, in banks, in various big financial organizations, you have regular audits to check. So the term is borrowed from there. So here also you do audits of the algorithm. Since the compass algorithm itself is not made public by North Point, you don't know what is the internal working of the algorithm. So you try to mimic the algorithm and check whether its predictions tally with the ground truth that you have collected. Okay, so we'll stop here and see you next week.
Excuse me, sir.
Yes.
Sir, is there any Teams code for adding us to the group because we are joining from the link?
This is a very difficult task. So what happens is that I need to have an Outlook installed in order to give you an invite. Otherwise, I'll have to give you invite one by one, and giving an invite one by one to the whole class is like a tedious task. That's why I have shared this link with you.
So you can share the Teams code.
Teams code. Okay, I'll try to see. I'll try to see if that can be done. Okay, fine.